I kind of want to review it real quick, and I've got a little handout that I want you guys to work on. But what we did last time, I'm not going to redo the proof, but we looked at something like, I can't remember exactly how I said it, but if I have the log of a product, how can I rewrite that? So what's the base? B. For both M and N, the base is B. Do you guys see that?
Yeah.
Agree with me. So what do I do when I multiply things with like bases? Add their powers. Yes? We know this. X squared times x cubed is x to the fifth. Because now I have a chain of 5 x's. Is everybody with me?
Yeah.
I detest memorization. I'm like, please, dear God, if I have to that's why I hate biology. I'm sorry, I do. Because there's so much memorization. I'm like, I don't care. I just want to know how to do shit. I don't care about the name is. So my God, as a student, I feel like you guys sometimes feel I've got to memorize every single thing. And I'm like, if I had to memorize everything I'm able to do, I think I've said this before. I'd be a blubbering mess in the corner. Are you okay? Oh, leave him alone. His brain is gone. So, every property of logarithms is exactly the same as a property of powers, because like you guys just told me, a freaking log is a power. So when I have things with the same base and I multiply them, I add this guy's power to that guy's power. I add the powers. You told me this. When I multiply things with like bases, I add the powers. We proved this one last time. I think I used different letters, but it's the same idea. You guys with me? Let me stop for a minute. Okay. This is trippy. This looks weird. But it's just because logs are weird. And they act the same way exponents do. So, I hesitate to do this, but I want to show you guys. If I had like the square root of 20, did we do this last time? Do you guys remember how to simplify this?
5 and 4.
Yeah, square root of 4 times square root of 5. I'm allowed to do that because it's a property of roots that I can break up. As long as they both have the same root, I can break them up. That's how roots work. So that's why we have to know how logs work, so I can break it up, I can simplify it, I can do all this kind of stuff. Yes? Okay. This one, I can do part of it and leave part of it. So let me show you an immediate consequence of this. What can you do with this? Holy shit, that's a mutant W. Can you do anything with that? Not yet. No, you can't. Because I don't have log base 7 of 7 anywhere. I've got like log base 7 of 7W. That's what I got.
Take it out and then cancel it?
Because what's the rule say? What can I do? Do I have the product inside of a log? The product of two things inside of a log?
Yeah.
What's multiplying in here? 7 and W. So do I have a product? M is 7, N is W. Yes? So what can I do? The log of a product is the sum of the logs. You can break it up. That's just how logs work. When I multiply things with the same base, I add the powers. Now hit me with what you said. What's this?
1.
Yeah, that's 1. And what's this? I don't frickin' know. Same thing up here. What's the square root of 4? 2. What's the square root of 5? I don't know. So if we say, I don't know, we just leave it, because I don't know what to do with it. You guys kind of with me?
Yeah.
I got to be really careful, because sometimes students start to think logs are roots. They are very different. But they have some similarities, right? The root has the multiplication, the log has the addition. So they are different, but it's kind of the same idea. I do the part I can, I leave the part I can't. Can you stop for a minute? Then I didn't prove this next one, but I just kind of pointed out how the idea could be applied again. how does this work? If when I multiply things, I add their powers. When I divide things, I...
Subtract.
So this guy's power minus this guy's power. And I just gotta keep coming back. You guys told me earlier, logs are powers. And that's why I keep saying power minus power, because that's freaking, they are powers. Okay, maybe. So a lot of mathematics is not immediately intuitive until you remember what things are based on. If you remember a log is a power, these make sense. They're the same properties as properties of powers. And I think, did I make it? Meh. Okay, you have to excuse me, because I've always had a bad memory. I don't care how old I was, and it's just getting worse as I get older. It's fantastic. I don't remember, I'm pretty sure I proved the last one. Did we get to plog?
Yeah.
Yeah.
Okay. I figured if we did, you would know what the hell I meant. But just to show everybody, in case you weren't here or you forgot, if I have something with a power raised to a power, what do I do with the two powers? Like x squared to the third power. What do I do with the powers in that case? No, you don't add them. Because what does it say? What do I have three of? So if I have three groups of two, that's the definition of what operation? Multiplication. That's the three crates with two apples in each. Three groups of two. Basic multiplication. So that's 3 times 2. I have 6 x's. 2, 2, 2. I have 6. Is that cool? So when I raise something with a power to a power, I multiply the powers. Now, we normally don't say all that. That's really what's happening. But what's the shortcut? When I have the inside of a log raised to a power, what does that power, what can I do with it? Put it in front. Now, by itself, that's trippy as shit. But if you remember logs are powers, that actually makes sense. And yesterday, I'm pretty sure I proved it. We started with like PMs or whatever it was, and then I rewrote it using the first property, and then blah, 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 blah. We did that. We proved it. This one is the most important rule, which makes number 1 the most important because that's how we proved this one. Okay. All of them are important, don't get me wrong, but this is the one you use the most. And when you get to calculus, in fact, in here, obviously, you'll see what I mean. So, let me show you just a couple things, and then I want to give you this worksheet. If I see this, you can do it, Jeff. How could I rewrite that? Yes, M log W2. Yes? You guys with me? And if I see this, so all the rules in mathematics, right? Everybody be jealous of this. Math goes both ways. All the rules go both ways. So if I can pull it down, I can put it back up. So what does this become if I wanted it to be? Yeah, log A of B to the, no, just this goes right back up. And you can write this as this if you want to. What's another way to write B to the 1/2 power? What's a 1/2 power mean? Square root. What's a 1/2 power do? Cut something in half multiplicatively. What else does that? Square roots. Okay. How you guys feeling so far? So let me give you this. Let me give you this handout. It's got all 3 rules, and I've got several problems. So I want you guys to try these problems. I am not going to force you to groups today. You guys can work by yourself, or if you see people near you that you want to work with, go for it. Call me or Christine over if you need help. Shut up. There's a couple at the end that are a little more. Hi. Sorry guys, we're probably not all quite fully done, but I'm gonna start to catch up to you. Okay. I need you to understand, I proved to you that these properties work. That does not make them any less weird, right? Logarithms are weird, they just are. But I really hope you understand why they exist. If I have a function that puts numbers in the exponent, I need to have an inverse function where the answer is what would have to be in the exponent. So I have to have that. That's all a log is, and that's why it's weird. It is an inverse function. Inverse functions are almost always a little weirder than the functions they came from. This rule is nice. So if I have a product inside of a log, I could break it up, or if I have the sum of two logs, same base, I could put them back together. Really quickly, if I have this, what can I do with it? Can you guys see that? If I have this, can I do anything with it? Does it match any rules? I can't do a damn thing with this. Nothing. If I have two logs adding, I can rewrite it as one log of a product. If I have addition in the log that doesn't match any rule, there's nothing I could do with this. Not directly. I don't know what X and Y are, so I can't do anything. But it's a really easy mistake to make. So I have a single log of a product, so I can break that up into what? Log 3 plus log 3. Be careful not to the power of, but just of x, right? Okay. We write the 3 as a base. That doesn't mean these are powers. Is everybody cool with that? We just write the 3 as a base. It doesn't mean it's like 3 to the third power or something. Yes? Okay. And what part of that can we do something with? Obviously. We can't do anything with this dude. But what's log base 3 of 3? 1. Yeah, kick ass. So it's just like the square root we did earlier. We did the part we could, and we left the part we couldn't. That's as much as you can do. Here, now I'm going to go the other way. I have the sum of two logs, same base. What does that mean I can do? Three. Yep, 3 times 4. There we go. So that's log base 12 of 12. And what's log base 12 of 12? Whoa. Okay. I like it. And I think I did this. Did I do this problem last time? Does anyone remember? Because I try to make a big deal. Does anyone know what log base 12 of 3 is? What power does 12 need to become 3? If you think about that for a moment, you're like, I don't have a freaking clue what that is. What power do you raise 12 to make it become 3? I don't know either. What power do I raise 12 to make it become 4? You're like, I know just as well as the other part, Jeff. And what's trippy is when you add both of these weird freaking numbers, and I know there would be crazy decimals. Yes? They would both be crazy. What do you raise 12 to make it become 3? Are you kidding me? Nothing nice. What's 12 to the first power? 12. What's 12 to the 0 power? 1. So between those, between 0 and 1 is the answer to this. It's like 0.3948. Who knows? Are you guys kind of with me? I need you to be with me because this is so cool. I don't have a clue what that is. It's ugly. I don't have a clue what that is. It's ugly. But when I add them together, it's freaking 1. Trippy. Okay, maybe. I don't know. It's like, calm down, Jeff. I'm sorry. It's exactly the same as, do you guys know what the square root of 2 is? Exactly? No? Do you know what the square root of 8 is? Exactly. I have no idea. But what's the square root of 2 times the square root of 8? Which is, all right, same way, right? 2 weird ass things. These are both disgusting decimals. But when I multiply them, I actually get a nice whole number. Yes? Crazy stuff. So same thing happens here. I get a log base 4 of what? I'm adding things with like bases. So I'm allowed to put them together. What do I get? Log base 4 of Yeah, 1/3 of 12 is 4, which is 1. Okay. Sorry, better calm down. Normally I'm about dead at this time. I have energy. I don't know why. But I'm just gonna enjoy it while I can. And you all are like, calm down. Now we move on to the quotient rule. Yeah, I think we'll do this and then I'll show you something. Yeah, we'll finish the sheet and then I want to show you one thing that makes the quotient rule maybe even make a little more sense. So quotient rule is analogous to the product rule. If I subtract two logs, I can rewrite it as the log of the quotient, or if I have the log of a quotient, I can break it up into two logs subtracting. And again, when I divide things with like bases, I subtract the powers. That's where that kind of analogy comes in. So of course, how do I rewrite this? Yeah, log base 3 of 3 minus 5. Log base 3 of 3 is
1.
log base 3 of 5 is, I don't know. Okay. So we do the part we can, we leave the part we can't. Same thing we do with square roots, right? And then part B is just going the other way. I have the difference of logs, I can put them together. How would it look when I put them together? And what's 75 divided by 3? And what's log base 5 of 25? 2! Finally, a different number than 1. I love it. Okay. Right? Because again, what do you think when you have a log in front of you? You think, how many bases make the inside? What power does the base need to become the inside? Part C, you could do two different ways. Yeah, okay. Part C is perfect what I was thinking about. How do I rewrite this the same way I rewrote the first one? What would it look like? Log 1 minus log 10. Now, here's the funny thing is, you know what both of those are. What's any log of 1? 0. Because you raise anything to the 0 power to get 1. What's log 10? Because what's the base understood to be?
1.
No, I'm sorry. The base is understood to be 10. That's why log 10 is 1. Now, go with me for a second. What's another way to write 1 over 10 using powers? 10 to the negative 1, yes. Because what's the negative power mean? Flip. You guys with me? And of course, what do these two do to each other? So what's the answer? Same answer we got, just a different way, yes? So why does it make sense? Let me show you if you guys are with me on this. Why does it make sense that quotient rule is subtracting? Because I got a dude on the bottom. In fact, let me do this. All right, Jeff, calm down. This is so cool, though. All right, it's okay if you don't think so. I'll be all right. Let me see if you guys are cool with this. Do you see how the y is on the bottom? If I force it up top, won't it have a negative power? Because wouldn't this make this go back down and be the same thing, yes? And then if I use the first rule, but then what can I do with that power? Sorry. What can I do with that power? I can take it down, so that becomes a minus. So why does it make sense that the quotient rule has a minus in it? Because one of the things is on the bottom, it would have a negative 1 power. That's why this has a minus there, yes? The same idea comes into play in calculus, believe it or not. It's really, there's the same name in calculus, quotient rule, but it means something very different. But what I just talked about actually comes into play there too. See if you're whoever teacher you take, if they talk about it. Okay. And then we get this. So this first one's pretty straightforward. What happens?
2 log base 3.
Yeah, the 2 just comes down. Now here, this is a little bit trippier, but have I gone off of my rants about radicals yet with you guys? Okay. I am that old man. I'm the old man who tells the same story over and over, so stop me. Radicals are done. Short thing of the story. How do I rewrite square root of x?
Next to the 1.
X to the 1/2. And then it's apparent what I do, yes? What can I do now?
Make it up.
Take the 1/2 out. Okay. This one trips people up, and I kind of created it to trip you up a little bit. I just had this whole rant about square roots and so forth, but you don't have to do shit here. Why was the first one easy? Why was the first one easy?
Straight up.
Because I just had a thing with a power, and the power just comes out. Do I have a thing inside a log base W with a power? What's the power? So that whole thing just comes out. You don't have to rewrite it at all because it just all of it comes out. I can't stress enough how important logarithms are. They feel like maybe this little thing, this little side note. No, they are it. They are huge. When you take calculus, they are going to be everywhere. Not everywhere. They're going to be a lot. They're going to be there decently often. So I want to make one thing really clear right now. How do I do this? We already did a problem like this, but I'm just going to put in a natural log there. Come on, you can do it. How does every log work? What can I do? Do it again. Yeah, that 2 can just come down. Is that cool? I don't blame you guys. I figure you guys probably got quiet because you're like, he's doing something weird now. Do you guys understand how these are not the same thing? This is very different from this. And this one, what's being squared? A, just A. So the thing inside the log is being raised to a power. That power can come down. What am I squaring here? The whole damn thing, I can't take that 2 down. That's not the property. I can only bring powers that are on the inside down. That's another mistake that calc students make. And it makes things easier, but they get to the wrong answer quick. It's not good. Okay. Now, I think some of you guys didn't quite make it down here, but several of you did. So here's the trick. Not trick, but both of these have the same first step. Do we all know what log base b minus log base b, like I have the subtraction of 2 logs, do we know what to do? Do we know what to do? If I have log base b of a minus log base b of n, can I rewrite that? Do we have a property for that? Yes, that's the quotient rule, right? Do we have a rule for log base 3 of something minus 2 log base 3 of something? Is there any rule for that? So I want you to see how to look at this. What is in our way to make it exactly match with the rule? What's in the way? What's the thing that's in our way? The 2's in our way. Well, good thing we could do something with the damn thing besides erase it and hope I don't notice. What can I do with the 2? Bring it back up. So every single one of these, the devil inside. No, every single one of these you can do both ways, right? So that 2 can go back up. Just like that, you can go, so if I have a power, I can bring it down. If I have a coefficient, I can bring it back up. When do I do which? Depends on what I'm trying to accomplish, right? Right now, I'm just trying to do what I said, combine it into a single log, yes? Now, what's the log base 3 of stuff minus log base 3 of stuff? How do I rewrite that? Yes, so the log base 3 of stuff divided by stuff. Now, if you stopped here, that's not good, because now, inside the log, I have a rational function. And what can I do with this dude? Can I do anything with this guy? I can ignore him, Jeff. Is that valid? No. What can I do at the top?
Take out W.
Factor it, but you can't take a W out. This guy has no W. Factor it. How would you factor W squared minus 1? W plus 1, W minus 1. And then what happens? Let me write the bottom twice. You can see what happens, yes? Done. And then you get log base 3 of W minus 1 over W plus 1. So this is just an illustration where every single thing we learn could just become one step in a bigger problem. We know this. So now we know how logs work. I could do logs and then I still have more work to do because the stuff I collect together inside could possibly do things, yes?
I was gonna say, could you take it a step further as well and then cancel the W's and then just have it?
Oh, no, be careful. Can you reduce, here, can you reduce, you can do it, Jeff, you can do it, Jeff, let me think. Well, shoot, everything's gonna work the same way. Can you reduce 8 over 9?
No.
Even though this is 8 over 8 plus 1, yes? Okay, so I can't kill things in a minus and a plus because division is not the opposite of those.
Right.
Okay, good. It's very human, I've heard. Humans enjoy, you just want to kill things, I don't blame you. Mathematically. Put it out there, okay. So yeah, your brain sees W over W, you're like, please let those die, but you can't. And let me say something really weird. There is no W in there. There's no W in here. There isn't. There's not a single W in here. There isn't. There's a W minus 1, which is not equal to W, and there's a W plus 1, which is not equal to W. So the top and the bottom are not the same, they won't reduce. Okay, maybe. Oh, that's really dumb, Joe. So if I make W2, this would be 1 over 3, yes? And nothing cancels there. 2 minus 1 over 2 plus 1, that's 1/3, that doesn't reduce. Because there is no 2. There's a 1 and there's a 3. Okay, maybe. Okay. Whenever I say that, there's no W, I'm thinking somebody out there's like, he is definitely off his meds. There's a W right there, but hopefully you guys see what I mean. Same way with 8/9. Is there an 8 in the bottom? No. There's a 3 in the bottom, 3 times 3. There's no 8 in the bottom, even though it's 8 plus 1. Okay. What about this last problem? It's really just this first problem, kind of like on steroids here. What do I have to do?
First bring the
Yeah, all the powers can come back up, yes? So I have log base big ass B of r to the 1/2 plus shabooboo. Now I'm going to try to show you a shortcut. You don't have to use the shortcut. What's the only log up there that's negative?
log.
Sorry, I'm sorry. I just liked that you just log. I just that was funny. Sorry. Which one? I'm sorry.
Log base B F.
Yeah, the ones with the F's. Yes. You with me? That's the only one that's going to end up on the bottom. Because when do I divide? When do I write log of a division? Subtracting. And the only one that's subtracting is the last dude, yes? So let me see if you guys can see this shortcut. I'm just going to write log B. When I add, I multiply. When I subtract, I divide. Done, yes? Anything that's negative is going to end up on the bottom. Anything that's positive is going to end up multiplied on the top. Come on. I'm just using both properties at once, yes?
Oh, just the 2/3 out.
Oh, I left the 2/3 out. Sorry. Chihuahua. Okay. All right. Sorry. So of course, everything about logs is less immediate because we don't use logs as often as roots. We understand roots better. Square roots, cube roots, because we use them more often. Logarithmic properties, a lot of people work with logs, but sometimes they don't even get to the property. So I don't know if anybody in here right now is like, I don't think I ever learned this before. That's possible, especially during the pandemic. Who knows what was left out. They are a little trippy. They are not intuitive, but they're all based on powers. So if this isn't clear by itself, you do have to memorize these. Yes, you have to know these. Okay. And these are exactly the kind of problems, especially the ones down here, that I like to give. on tests and quizzes and shit. So, last thing for the day, and then we'll get out of here a little early. The next thing we're gonna do. So, we started with exponentials, and we just worked with exponentials. We graphed them. You guys with me? Everybody's looking at their phone. Oh shit. Oh, well, talk to the two of you. Maybe called them out. They're still going. We did exponentials, and then of course when we create a new function, we want to see does it have an inverse. So we found its inverse, which are logarithms. We graphed those like crazy, and then we talked about how the hell do logs work. So we just did the properties of logs. The next thing we do in mathematics is what do we do if these are in an equation? How do I solve an equation with these in it? Yes? That makes sense. We solve all kinds of ways. We talk about squares, and we go, what if there's a square in my equation? Then we got quadratic and blah, 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 yes? So what if I had an equation, let's say it looks like this. How do I solve it? How do I solve that damn equation? This one is nice. This one is fantastic. I don't know if anybody can see why this one is so nice. Is there another way to write that expression without a logarithm? Man, I don't know, maybe put it like your dirty clothes, where your dirty clothes go. God, I hope I said washing machine with you guys. Huh? Did I say, I'm sitting up here like, did I just say that in my other class? And you guys are like, why is he bringing up dirty clothes? Washing machine, right? Put it in exponential form. So how do I put it in the washing machine? 3. Uh-oh. To the -2, because what is this? It's a power. A log is a power. Equals x. So 3 to the -2 equals x. Do you see how we solve the equation? Just what is 3 to the -2? 1/9. So that's the kind of equation you're like, Jeff, give me all those. Give me as many of those as you want, Jeff. I'm not going to give you money to that. That's beautiful, right? So when you have a logarithm, it's got a variable stuck in it, you can rewrite it as an exponential and free it up. So what if I had, so this kicks ass, yes? If I have log equals number, I could do it. So what if I had, of course, I'm not going to always have that. Here, let me number these to make them look like imaginary numbers. What if I had this instead? Uh-oh, I got to make one that works. Give me a second. Oh, I don't know what I'm doing. Okay, let me see. You can do it, Jeff. Can you? I think I can. Yes. Okay, wait a minute. Okay. Yes, that should work. What is the big problem here? Do I have log equals number? Is that what I have? No. If I had log equals number, I could do like we did the first problem, right? So my main problem here is I got too many frickin' logs. Do we have a property where we could shove them together into one mega log? What property could I use? What am I doing with the logs? I'm adding them so I can rewrite it as 1 log of the product. So those properties we learned aren't just little extra shit that I'm gonna grade you on and make problems with a whole bunch of stuff in it and bahaha. No, it's actually a method to solve a damn equation. And an equation like this, I just made that shit up. I did, I totally did. But when you get into whatever STEM field, you will have observations you make that follow a logarithmic pattern. So your equation will have logs in it. And then you have to solve for the damn variable so you know what the shit to do. So you have to know how to solve these. Okay. If you're using computer software, I almost don't care. Because the more you understand how equations work, the better you can input shit. And you know what to do when there's a mistake. Okay. Now, do I have, let me write that a little cleaner. Do I have a single log of stuff equaling a number? So how can I rewrite it? 3 to the 3 equals that. So I got 3 cubed equals this. Do you guys see? It's kind of nice. If I have a single log that kicks ass, if I have 2 logs, okay, put them together and it kicks ass again. Now this kicks a little less ass because what do I have to do to solve this? See who remembers. Is this side factored already? That side's factored, yes? But what's the only number that could be here that would help? What number should be here that I could solve then? You could do it. What number do I wish that was equal to? Because then I could just see the answers. 0. Is this 0? Damn it! So, one way to look at this problem is, and we know this isn't true, but one way to look at it is, oh, somebody factored too early. I gotta multiply that out, subtract this over, make it 0, and then refactor. Yes? Can you guys do that? I'll wait. So FOIL it out, subtract the 27, try to refactor. Let's see if Jeff made a problem with nice answers. Pretty sure I did. Oh, I did. Okay. Holy shit, Jeff. So what do you guys get when you FOIL it out? Cool. And then what did we want over here? We want 0 over there. And now that we have 0 there, now it's time to do what with this? Factor, kick ass. Go for it. Two numbers that multiply by negative 32, add to be 4. What are those? What are those? 4 and 8. And of course the bigger one has to be positive. So what do I get? I get x equals 4. X equals, nope, negative 8. Now, real quick, who remembers what a log looks like if I graph it? Can anybody show me in the air what a log looks like? Okay. What's happening right here? What's this? What's this?
Vertical.
Vertical axis at x equal 0. So therefore, no inputs below 0 or 0 itself works. You can only input positive numbers. Now, we have 2 candidates for answers. If I plug a 4 in, do either one of these become negative? 4 minus 1 is 3, 4 plus 5 is 9. Log base 3 of 3 is 1, log base 3 of 9 is 2, 1 plus 2 is 3. That's how I made the problem, by the way. I just picked a value for x and then just kind of made it work out. If I try to plug a negative 8 in, what happens? Negative 8 minus 1 is, that guy's gonna what? If I put a negative 8 into him, what's he gonna think? What's gonna happen to this guy? If you try to plug a negative 8 in, can he handle that? Can he handle negative inputs? So I really want you guys with me. Log looks like this. Yes? I cannot put negative values in. There's no outputs back there, are there? Which makes sense because if I put a negative number in, what do I raise 3 to make it become negative? There is no number. 3 to a number bigger than 0 will make it just 3 to a negative number makes it small positive. Nothing makes it 0. Nothing makes it negative for damn sure. Yes. So logs can't handle negative input. So what do I do with this guy? What do I do with him? Throw him out. He's not an answer. That's the only answer there. So I'm trying to remember if we've seen extraneous solutions before. I feel like it's possible we haven't, to be honest. But that's called an extraneous solution. And by the way, we did all the math perfectly, and we still got an answer that didn't work. You guys with me? So part of that you should feel like, what the shit, math? It's not math's fault. We did something that was weird. Right here, if both of these numbers are negative, what do I get when I multiply them together? What kind of number? And then this has no problem. So the minute we took this and rewrote it, we lost information about how bad it is for both to be negative. So math was like, oh, the one you just wrote, it's got these answers. And we were like, oh shit, we started up here, we made them both negative. We're sorry, math. I don't know if you guys are with me. Because as a student, it sometimes feels like I did everything right and the stupid math gave me a bad answer. It's because we did something to the equation that caused the bad answer to show up. We just don't know till the end. Maybe. All right. I think that's plenty. That's plenty. You guys are kind of looking at me like, please let me out of here. Okay. So tomorrow I'll have the quizzes graded. We'll get deeper into solving some of these equations. I'll have the practice test, because that's going to happen after the spring break. Not immediately. The day we get back will be review day. There you go. Hopefully your spring break's going to go well. I have good plans, so I'm happy. I'm hopeful.